Hello everyone, it is Mike Levin on Sunday morning still at around 11 a.m. March 6th, I believe. Anywho, I've been listening to Max Tegmark's book about the universe is not what you think, how we live in a mathematical universe, how he proposes that what we're experiencing is essentially the playing out of mathematical expressions, and that is reality. And how unlikely is that really? Are we not all, since math turns out to be the language that is astoundingly well suited for describing how things work in the universe, isn't it also a logical next step that we are in fact the product of purely mathematical processes? And it's just a little bit mind-blowing. There's a lot to absorb in that book. And he talks a lot about Hugh Everett, which is where a lot of these ideas originate. He was a Princeton physicist who wrote his PhD paper on what has come to be known as the many worlds interpretation or multiverse theory, in which all the collapsing probabilities of quantum mechanics states that things live in a state of superposition, neither here nor there, until the waveform as defined by the Schrödinger waveform collapses. It's where particle-wave duality allegedly comes from. Everything is really just a wave, and on occasion can get expressed as a particle. There was a debate there a while for physics that it's when human observation was available, so that reality only occurred when there were humans, particularly humans, there to view it. And then those human-centric views gave way to more practical views that it's the interaction of any particle-like components of a system that collapses the waveform. So the waveform is somehow collapsing all around us all the time and creating one continuous thread through all the worlds of probability, which is our reality. The read-write head on the Turing tape is us. And there's a lot of explanations for how waveforms collapse, and Hugh Everett was one of the people who said, hey, wait a minute, what if the waveform never really does collapse, and our perspective, our viewpoint, our unique selves that we feel ourselves to be is only one of the possible infinite threads through the threads of the four-level, as Max would say, the Swedish guy, the more modern physicist who's writing the book on all this multiverse stuff that's looking back on the work of Hugh Everett and such, is postulating that we live in a four-level multiverse. And he goes through and he describes what each one of these multiverse or universe types was of the multiverse, some being just observable universe. And if space is infinite, it's a big if because it could wrap back on itself, but if space is infinite, then just through the probability and statistics of infinity, there are other universes that are just like us out there somewhere. Point in a direction, go that direction far enough, and you'll eventually be in the next non-overlapping observable universe, type 1 multiverses. And he goes on to explain it can be in Hilbert space, something like that, where you got spatial coordinate systems. Of course, if stuff is in the X, Y, and Z axis, it's located in very traditional Euclidean, I believe it's Euclidean space. And if you add time, Euclidean space-time. But, relativity shows us that space-time bends, so it's not as clear as you think. There is not a perfect stage upon which reality plays out. There's a lot of different theories out there about how it becomes to look like a stage to us, because it looks like a stage. We have our human perspective on things, and that does indeed count for something not insignificant. And so one of the multiverse theories, one of the many worlds theories, has it that because waveforms don't collapse, it would say they don't collapse, there's never a moment of collapse, our unique perspective is just that, thread running through the 4-level multiverse, which is the pure mathematical version of our universe, that all universes are derived from pure math. That somehow there's a way for this math to be run, for formulas to be carried out, to express those things that we come to know as 3D space, time, and particles, and even all the randomness, the seeming randomness that we have of quantum mechanics. It's only randomness from our perspective. One of the great prizes, the $1 million math prizes, is figuring out the random pattern behind how quantum foam pops in and out of existence, the rippling of our very, substrate of reality. That rippling of what reality is causes a light sprinkle or dusting of snow of quantum particles, virtual particles, to pop in and out of existence, exactly like other particles, but I do believe it's either lower or higher mass. They either have mass where their photons equivalent don't, or they don't have mass where their photon equivalents do. I always get it confused, but quantum light particles, quantum photons, and there's all kinds of particles popping in and out of existence. Photons don't have a lock on the quantum foam. There's apparently, on a much more rare basis, all the different particle spectrums just popping in and out of existence. And they all have analogs in the more persistent type particles that we come to know as, everyday, parts of the atom and the energy surrounding it, like electrons. So, so the multiverse books and all this abstraction and where I want to go with it and how I want to wrap it up quickly, because I started this little video already close to the end of the line here. Well, it's on my mind a lot. This is really heady stuff, and it makes you speculate about our role, if any. How big or small are we? The human perspective swings between center of the universe, created directly by God, back in the Greek days, believing, us at the very center, and then the tearing away of that through, all the various discoveries of science, until such time as even our very human consciousness may be nothing but layers of pattern recognizers. Modern machine learning advocates would have us think that we have the building blocks, we have the basic components now. It's now a matter of, cost reduction and optimization of the hardware, energy efficiency, more configurable into neural networks, silicon and things like silicon, and increasing memory storage capacity, having, nearly unlimited memory of a not purely digital form. Not everything needs to be digital memory. There's such a thing as fractions and vectors and directions, which could be encoded and stored as digital. So somehow it seems like it always gets back to digital. Even as we tear away the riddles of DNA, how it can both be the way of encoding information and the means by which that information is actually put to use. I had a wonderful discussion the other day, it might have been yesterday, I'm not even sure anymore, about how the Lisp programming language that I spoke about a few languages back was modeled to be like a very reductionist approach to information systems, such that with their S functions, I called it, a single pairing of two elements held inside parentheses, It's a simple one-to-one relationship between two objects, the atomic unit of key-value pairs. You've got a key side and a value side, and how that gets linked up in chains, longer and longer chains, to express everything that needs to be expressed in computer science, from the storing of data to the processing of that data. Compilers are often written in Lisp to move things between the worlds of existing as code on a hard drive to existing as something you can drop into the memory of a known piece of hardware and start executing code, dropping things in memory locations and having the predicted results you want. Highly deterministic systems, the EXEs and the ELF files, the compiled binaries, the output of a compiler. And this is really, really, really heady stuff, because as much as comp sci departments might teach you that there's one way things work, it isn't true. There are many ways things work, and nature itself provides many models. And Lisp was modeled as a programming language after some of the most flexible, reductionist, and robust approaches that we can infer about nature. And yet, even though that was done back in the 1960s and 70s at the MIT lab under Marvin Minsky and James McCarthy, the two guys who headed up the media lab back in those days, my wife, Nat, pointed out to me a quote by, I think it was Minsky, how now that we have these building blocks, it is very much assured we will have artificial intelligence, machine learning, in anywhere from 4 months to 400 years. So I might have the quote a little bit wrong, but it very much expresses how they knew they were getting into a waiting game for machine learning and artificial intelligence, call it what you will, because of hardware, because of the bottlenecks of the modern architecture that crams everything through a CPU, which can be forced to simulate neural networks, but it has to go through as many clock cycles to calculate the output of each neuron as you have neurons in the network. And of course, if it's a thousands of neurons neural network you're simulating, it takes thousands of clock cycles to do what could be done in one clock cycle if you had something with 100 or 1,000 little neuron processors, much smaller than a CPU, and very similar to what's in GPU cards, the things that NVIDIA and AMD have been putting in their Radeon different cards over the years, and all this stuff has been gobbled up by the different companies now. I think Intel owns one and AMD owns the other. It used to be these two different graphics cards that were used for the 3D immersive games like, Duke Nukem back in the day. After Doom, and before what we know today as the, unbelievably 3D immersive, 3D multi-user online systems. Oh, I got the battery warning, and I'm almost there. So this is a good video. I'll wind it up fast. We know that GPUs are good for neural network type things. They're also good for cryptocurrency hash mining. Another story. But I went into all these stories. It really became, story time with Mike, with, my wife and a friend who are sincerely interested in this stuff. They're getting into 3D printing. One of them put themselves on Unix, or not Unix, but Ubuntu, Ubuntu desktop as her main platform. And so I'm helping them get through these various issues. Not much. I'm letting them mostly learn to fish on their own. But I like to tell the backstories, because this stuff that they're starting to use has such interesting backstories, and I keep running into the, perfection, the desire for the uncompromising approach. It's all in your head and imaginary anyway. You're collapsing the waveform, and bring it back to collapsing realities, right? Multiverse theory. So it's very clear in computer science, the division between deterministic systems and the programming thereof, using languages that use static typed variables. So generally, your program can be compiled into an EXE, or an executable that can be dropped right into the a known memory space on known hardware and start doing its thing, because it's all a bunch of lookup tables and stuff, dictionaries and lookup tables all wired together to have the illusion of being a program or an application that you're using and interacting with. So, most things are that way, really, in computer science, because even in commercial hardware and software, because that level of determinism makes for solid systems that don't crash on you. I talked about the Amiga computer and how it was ahead of its time, and how everyone is so enamored with going through the technology honeymoon with for the first time. I had, right down to augmented reality through Mandela and the video toaster, in the early 90s, 1991, 1992, before even the rise of the web. So I have oh, that's nice, I've seen it, not only seen it, but had it in my own hands before. I had a Amiga 2000 suited up with a video toaster and a Mandela virtual reality system that I gave to a friend because it was too much matter to have in my life, which gets into the story of matter that matters, matter that doesn't matter. I got rid of an Amiga 1000 that my friend Adam Edwards almost wanted to beat me up for. It was even one of the early ones off the production line. And I just trashed the thing, except for its lid, which had the signature of Jay Miner and his dog Mitchie's paw on it, which is all that I really cared about. This was a wall trophy piece. I'm never going to instantiate this running hardware again. It might have some historical interest, but I have really started stripping away matter that is the equivalent in one's life of old friends, which seems to have some symbolic meaning, but hey, you gotta live the life that's around you, and local space has a lot of importance. And if you bog down local space with too much from very, very past histories whose invocation is difficult, impossible, not of much value, then you're just carrying around a ball and chain dream, a symbolic representation of a thing whose time is gone and over. So I got rid of that decked out Amiga 2000, probably with a GVP 68040 accelerator, a video toaster, Mandela virtual reality system. I guess that was the InVision capture board. I refer to Mandela, which is the software, but it was really the InVision, I think maybe TrueVision card that was doing all that collision detection back in the early 90s. And now our phones do it in 3D space. And it's just, we're seeing Oz, as in the Wizard of Oz, the Land of Oz, invented realities, augmented realities, come into reality around us. And sci-fi books keep entering my mind. Of course, one is Rainbow's End, non-apostrophe S, Rainbow's End, intentional, by Werner Vinge. I think it was in approximately 2006, and it predicted so much of this stuff. You should really read it. The Harry Potters versus the Pokemons. It's wonderful stuff. And another one is Snow Crash. It's a must-read. The emergence of artificial intelligence and the encoding and motivating of people into almost hypnotic action through the use of memes, although I might be confusing that with another Neil Stephenson book, Diamond Age. So Diamond Age and Snow Crash, two must-reads, both of them after the internet but before the web, and really, really visionary. So things don't have to be the way they are today. APIs, application program interfaces, emphasis on interfaces, human-machine interfaces, don't have to be the way they're expressed today. All bets are off, because we're on the verge of Oz. Wonderland if you prefer, but I prefer Oz over Wonderland. I'll use both as metaphors and analogies all through my videos and various descriptive things I'll be doing. They are in fact the backbone of my worldview, because what's important in your head is not only the openness and continuing ability to learn, but it is also using the lessons of what you learned recently and what you learned over long stretches of time, and the correct weighting of each. This is all machine learning. I tend to side with Ray Kurzweil, one of the Google fellows and founders of optical character recognition, that we probably are on the verge of being able to do practical brain scans and instantiating new human consciousnesses within virtual realities that can live a life much like the Bobiverse series. For We Are Bob, We Are One. You should Google it. It's a great Audible, read by, I think, Ray Porter. Profoundly good modern sci-fi. Very practical, very hard-hitting, very much my worldview, right down to propulsion systems, various forms of anti-gravity, and various ways that interaction with alien species and machine intelligence can all play out, and very much paying homage to the fact that APIs can turn out extremely differently, and are not necessarily better or worse, but they are good for different use cases by different types of people. And currently I'm in love with a Python API and Python API wrappers for all, and that is one of my key learnings of late that allows me to be a wizard in Oz. You want to be if you're going to live in Oz, you want to be a wizard. If you're going to be a wizard, you have to choose the type of wizard you want to be. And it gets very open-ended with choices, except there are some well-traveled paths that run through these collapsed probabilities, collapsed waveform paths, if you will. And it all starts to become very reflective of each other. Your brain is a quantum computer, I believe. Even if it doesn't work on quantum principles, it is, through thought, allowing you to calculate the superposition of multiple realities into the future. You're about to open a door. You do not know what's on the other side of that door. Your brain can fill in many possibilities from its imagination. Not all possibilities have equal likelihood, so there is a weighting system. And your brain weights which probability is most likely, and it makes a decision about what it thinks is going to be on the other side of that door, and then so it is not surprised when it opens the door. There is no triggering of the endocrine system to release fight or flight chemicals into your bloodstream, and you've opened the door to an empty doorway, and it's exactly what you predicted. That is a quantum calculation that your brain is doing, or at least it is of a quantum nature, because you have created infinite possibilities according to your imagination, prior experience, recent experiences. Is someone in the house with you at the same time? All with different weighting, all going through many layers of pattern recognizers to come up with an expectation, and then you collapse the probability by opening the door. But there's other universes in which you don't open the door, or you open the door to different things on the other side. And this is where multiverse, many worlds interpretation comes into play. I don't know how much I buy it, but it would have you believe that all these things are still happening, that there is forever forking realities around every place in which interaction between particles is done, because things always are on the edge. On the boundaries, things are on the boundaries. On the edge, things are on the edge. You're not touching something until you're touching it. And on the moment your finger makes contact with the thing you're touching, there's a calculus of whether you're really touching it or not. How much are you touching it? Is this touching it yet? Are the gravity fields being able to interact at some distance counted as touching? If a sensation doesn't reach your brain, that touching has occurred. What about auras, which are real electromagnetic emissions from our body because we're electrical systems? Overlapping auras, does that count as touching, or does there have to be pressing to the point of resistance, pushback between the, quite frankly, electrical fields around the atoms? If something feels wet, it's because of that. If something feels sticky or smooth or hard or soft, it's all because of the details of the outer electron shells, the valence electrons of the thing you're touching, and not just one, but a preponderance of them in such numbers that the experience can only be statistical in nature. And so our whole experience is statistical in nature. It's always based on a preponderance of evidence because waves and particles are so very small and we are so very large compared to them. And so we enter in what is truth. Truth. What is truth? It has to be a question in philosophy, in politics, in morals, and also in machine learning systems, as it turns out. So you can have data samples, input parameters that represent truth, and compare the learning of or the opinions of a machine learning system against truth, so that you can have these feedback loops to adjust the weighting, and that's how things become self-learning and get to know things better over time. And this is a trick that can scale, it can layer up, but not with yesterday's hardware, only with tomorrow's hardware. This is why we're getting neural chips in our iPhones so it can do things like face recognition, because unlocking your phone depends on face recognition now. They can't play around with it. So they needed some hardware in there that could do the neural stuff that needed to be done to say, yeah, that's his or her face. They're including, infrared, sensors and LiDAR in more modern iPhones and I guess Droid. And all these sensors can be sensory input to machine learning systems. And then it's a matter of, how it's all wired together, what kind of neural network, what kind of patterns it's designed to recognize, how persistent the data is. Is it in the cloud? Is it on your phone? Is it in some being that's going to have an identity in the future, a standalone robot? Or is it completely in virtual reality with no API or interface to the real world? And things that are learning inside of there only ever know things as they pop into that existence inside that box, like Moriarty in Star Trek. So anyway, I ought to wrap up there. This is one of my information-packed videos in a while. I did it all in under a half hour. I don't even know what I'm going to label it or title it, but I'm going to think through it for a while before I post this one, because I'm doing my updated SEO tools. They're going to be ML SEO. Again, that's ML SEO, and in not too long, it will be available to people, and you can do all the same SEO things that I do because I'm bottling it. What could make this product even better? Bottle it. So I'm going with a bottle it theory, and black Nissan Altima punching the gas to zipper one ahead of me and merging traffic. It's very interesting seeing, stereotypes. Maybe I recognize it because I've labeled it, but there's a powerful thing. Label concepts. It doesn't matter what you're labeling. The fact that drivers of different types of car models have particular driving characteristics and signatures that you can see reoccurring. And whether it's statistically significant or not is not a matter of just, do you recognize it there, it must be true, but it must be recognized and cataloged and be made part of some sort of learning index constantly with all the feedback, or else you're getting very biased results. And the fact that biasing exists in machine learning is also another very important issue. There's biasing, there's weighting. And so the location of your sensors, how light hits things, whether it's day or nighttime, all these things factor in. Learning is not a simple matter. Learning takes lots of tiny, tiny little adjustments. Things have to grow up. And machine learning systems that are going to strive to emulate life are going to need to be raised well, be evolved well, and be raised well. There's two important things in machine learning that must be tended to make sure that they turn out to be partners on this planet and beyond, rather than replacements. And that is, they need to evolve well. Their path of evolution needs to be a righteous and good one, producing types of beings that we'd want to hang out with. There's, insect drone routes for Department of Defense use that don't qualify on that criteria. Doesn't mean they won't exist. It just means that they're not the kind that we should encourage and promote. So evolved well. And then any particular instance needs to be raised well. Its scientist, person with a clipboard or what have you, its parent needs to instill good learning and thoughts and to deal with dangerous, unstable thoughts setting in with immediate interaction to resolve it in some long-term stable way. So you got a good AI here, so it's growing up well. Also read the Culture series. Okay. Thanks for joining me. Hope to talk to you again soon, and don't forget to subscribe, or else you are an affront. Ha! We are the affront.